Dear students, we are discussing Wronskian. What is Wronskian? Wronskian is nothing but it verify the given functions of linearly dependence and independence. For that purpose only we will use the Wronskian. Okay, suppose if they are given a y1 of x, y2 of x, so on like yn of x, or functions in terms of x alone. Now, to verify the linearly dependence, we will use the Wronskian. The Wronskian function is denoting with w of x. This is also is equal to w of y1, y2, so on yn. That is equal to determinant of y1, y2, so on yn. Now here this is y1 prime, y2 prime, so on yn prime. Like this, y1 n times we have n minus 1 times we have to differentiate, y2 n minus 1 times we have to differentiate, so on yn we have to differentiate n minus 1. You see, this is having n functions. To get the determinant, we required n by n matrix. Suppose if it is y1 of x, comma, y2 of x, comma, y3 of x, or three functions are there, then Wronskian of y1 of x, y2 of x, y3 of x is simply denoting with w of x, that is equal to modulus of y1 of x, y2 of x, y3 of x. Divide downside. Here in the first row we will write y1, y2, y3. In the second row we will write y1 prime, y2 prime, y3 prime. Next y1 double prime, y2 double prime, y3 double prime we will write. Okay. Now we will see one problem on this. Just finding the Wronskian. What we will get? Linearly dependence. Okay. Suppose here Wronskian w of x is equal to 0, then you can say those functions are linearly dependent. If Wronskian is equal to 0, then you can say those functions are linearly dependent. If Wronskian not is equal to 0, then you can say those functions are given functions are linearly independent. Linearly independent. Now we will see the problems on this. Verify the given functions y1 of x is equal to sin 3x, y2 of x is equal to cos 3x are linearly dependent or not. Okay. Now you see, to verify the linearly independent or dependent of y1 of x is equal to sin 3x, comma, y2 of x is equal to cos 3x, we use the Wronskian. We know the Wronskian of y1 of x, comma, y2 of x is equal to, simply we are denoting with w of x, that as determinant of y1 prime, y1 of x, y2 of x, and y1 prime, y2 prime. Okay. Now you see, first what is the y1 of x we have? y1 of x you write it. y1 of x is sin 3x. y2 of x is what we have? Cos 3x. What is y1 prime? y1 prime means the derivative of sin 3x. Derivative of sin 3x is cos 3x into 3. Cos 3x derivative is minus 3 into sin 3x. Now do the determinant for this. Now determinant for this means AD minus BC. So minus 3 sin 3x into sin 3x means sin square 3x, minus cos 3x into cos 3x is, here 3 is there, so cos square 3x. If you take and minus 3 is common, then you will get sin square 3x plus cos square 3x. That is equal to, we know that sin square a plus cos square a is equal to 1. So minus 3 into 1, which is minus 3, not is equal to 0. Therefore, the given functions are given function's Wronskian is not is equal to 0. Therefore, you can say linearly independent. Hence, what we can say, is it linearly dependent? No, linearly independent. Okay, now next problem. Next problem, show that linearly independent solutions of y double dash minus 2y dash plus 2y is equal to 0 are e power x sin x comma e power x cos x. Then what is the general solution? So first we have to prove the solution of these differential equations are linearly independent. What are the solutions they gave? These two solutions are linearly independent. How we will say the given solutions are linearly independent? You have to verify the Wronskian. If Wronskian value is 0, then we will go for, we can say the given functions are linearly independent. Okay, now write the Wronskian. What is the Wronskian means? W of x, that is W of how many functions are there? Y1 comma y2, two functions, because this is ordered to, and so that is why they are given two solutions. Okay, now Wronskian of y1, this is, you know that Wronskian is y1 y2 y1 prime y2 prime. Okay, now y1 is nothing but e power x into sin x, y2 is nothing but e power x into cos x. Okay, now e power x derivative is this e power x sin x derivative, UV formula. E power x into sin x derivative is cos x, plus now second term sin x into e power x derivative is e power x. Now this is, you see, e power x into cos x derivative is minus sin x, plus cos x into e power x derivative is e power x. Now we have to do the determinant AD minus BC type. So this is e power x sin x into minus e power x sin x plus cos x into e to the power of x. This one minus of e power x cos x into e power x cos x plus sin x into e to the power of x. From these all, I am taking e power x as a common. So e power x is common if you taken. You see, e power x into e power x means e power, you will get 2x. Okay, now from this also you see e power x inside e power x common, outside you have e power x. So entirely e power 2x is common. So now I am multiplying. This is sin x into sin x, sin square x, but sin is minus you have. Now sin x plus cos x, product is cos x into sin x. You see, already we are taken e power 2x is common, so minus cos x into cos x means cos square x. Okay, now cos x into sin x means cos x sin x. Here symbol is what? Minus. So we need to write minus into plus, minus only. So from this plus cos x sin x minus cos x sin x getting cancelled. This is minus sin square x minus cos square x. So minus you take common, then you will have sin square x plus cos square x. So you know that sin square theta plus cos square theta is what? 1. Therefore e power minus 2x into 1, that is minus e power minus 2x, which is not is equal to 0. Therefore w of x not is equal to 0. Therefore the given solutions are linearly independent. Okay, now we proved linearly independent. These solutions are, first these are solutions or not, we have to verify. Okay, see, these are linearly independent, but first we have to verify these are solutions or not. But what we are done now, first verified linearly independent. Anyway, once again we will check it, these are solutions or not. How we will check these are the solutions of the given differential equation or not. Okay, now you see, suppose I have an equation f of x is equal to 0. If I want to say alpha is the solution, how I can say here alpha is a solution? If f of alpha is equal to 0. Okay na? Now we will verify these two functions are satisfying this given differential equation or not. If it is satisfying, then you can say these are the solutions. Okay na? Now given equation is y double dash minus 2y dash plus 2y is equal to 0. Okay na? Now we have to prove y1 of x is equal to e power x sin x is a solution. We have to prove. Okay, solution, right? Now how you can say solution means it should satisfy this equation, nothing but y1 double prime minus 2y y1 prime plus 2y1 is equal to 0. It should satisfy this equation. Now we will verify. Okay now you see what is y1 prime. Y1 prime means e power x into sin x derivative. First e power x into sin x derivative is cos x plus second term sin x into e power x derivative is e power x. So you can write this as e power x common cos x plus sin x. I want y1 double prime also. So y1 double prime means double derivative of y with respect to x. So e power x you take common, sorry, e power x into this is uv formula. Again we have to differentiate y1 dash, then you will get y1 double dash na. So e power x into cos x plus sin x derivative is minus sin x plus cos x. First term into second term derivative plus second term into, that is cos x into sin x, okay, into e to the power of x. Derivative is e power x. Now from this you can take e power x is common, so you will get sin x, excuse me, here plus symbol I forgot. Okay, now e power x is common, then you write down the remaining terms what I have, minus sin x plus cos x plus cos x plus sin x. Okay now this is, if you simplified, then you will get y1 double prime is e power x. Here you see e power x, this minus sin x plus sin x getting cancelled, cos x plus cos x is 2 cos x, that is 2 e power x cos x. So now we have to substitute this y1 double prime and y1 prime and y1 value in this equation. If it is satisfies this equation, then you can say y1 is a solution. Okay now we will check it. y1 double prime is 2 e power x cos x minus 2 into y1 prime is e power x into cos x plus sin x, okay, plus 2 times of y1 means e power x sin x. So you take e power x is common, 2 e power x is common from this first term, second term, third term. Then the remaining terms are cos x minus, here you see minus, if you multiply for the both you will get cos x plus into minus sin x plus sin x. So what we are getting here, plus cos x minus cos x minus sin x plus sin x are getting cancelled, so you will have 0. Therefore what I can say means y1 of x is a solution of given differential equation. Now we have to prove y2 of x is also a solution. Okay, for that we have to prove y2 double dash minus y2 dash plus 2y2 is equal to 0, where y2 is this one. So we need to find y2 prime is y2 dash, nothing but e power x into cos x derivative is minus sin x plus second term cos x into e power dx derivative is e power dx only. I can take e power x is a common from this. I can get minus sin x plus cos x. Okay, this is y2 prime. Next to y2 double prime, nothing but y2 double differentiation. Now you have to differentiate y2 dash once again. So first term e power x into inner derivative, here bracket derivative is minus sin x derivative is cos x. Here cos x derivative is minus sin x, minus into plus minus sin x, plus second term into, second term is here minus sin x plus cos x into e power x derivative is e power x. Substitute y2 prime, y2 double prime in the given equation. Then you will have e power x into minus cos x minus sin x. I can take e power x is common, then I will get here, you see, minus sin x plus cos x. And what are the, here close the bracket. Actually we need to simplify, then these are getting cancelled, then you will get some term. Anyway I am cancelling here, these are cancelled. Next minus 2 y2 dash. So y2 dash is here, e power x is, you have minus sin x plus cos x plus 2 times of y2 means e power x into cos x. Okay, now from this you see I can take e power x is common. You have minus sin x means minus 2 sin x. So here minus 2 is there. Okay, here plus 2 is there. From that also you can take minus common. So minus 2 e power x is common. Then the remaining term is sin x. This is minus sin x is how much? Minus 2 sin x. No? So this one. Next to here already we are taking minus 2 e power x is common. So the rest of terms you write down. Rest of terms are minus sin x plus cos x. Here 2 e power x you taken, 2 e power x you have, but we are taken common minus 2 e power x. No? So if you taken minus common, minus from the plus you will get minus. This is cos x. Now you see, simplify, minus sin x plus sin x, cos x minus cos x getting cancelled. Therefore you have this term is 0. So the entire term is 0. Therefore what you can say, y2 of x is also a solution. Okay, now we proved y1 of x, y2 of x both are the solution of the given differential equation, and we proved those solutions are linearly independent. Okay, now we have to write the general solution. In the problem they given, write the general solution. How we will write the general solution means, suppose if y1 of x comma y2 of x, we know that y1 of x comma y2 of x are two linearly independent solutions of y of x. Then the general solution is, there exist c1 comma c2 are two arbitrary constants, such that c1 into y of x is c1 into y1 of x plus c2 into y2 of x. Now can you say what is the general solution for this given problem? c1 into, we have y1 of x is e power x into sin x plus c2 into, we have y2 of x is e power x into cos x. So this is the general solution. Okay, now show that y1 of x is equal to sin x and y2 of x is sin x minus cos x are linearly independent. So to verify the linearly independence, we will use the Wronskian. Okay, now the Wronskian is, we are denoting with w of x, that is equal to w of y1 of x comma y2 of x, that is equal to modulus of y1 prime, y1 y2 y1 prime y2 prime. Okay, now write down what is y1. Y1 is, they are given sin x, y2 they are given sin x minus cos x. Now y1 prime means sin x derivative is cos x. Now y2 prime, sin x derivative is cos x minus cos x derivative is minus sin x. So minus of minus plus. Now AD minus BC, this is sin AD minus BC, you see, sin x into cos x plus sin x minus cos x into sin x minus cos x. Now this is equal to sin x cos x plus sin x into sin x means sin square x minus cos x sin x minus into minus plus cos square x. You see, sin x cos x both are getting cancelled. Then you will have sin square x plus cos square x. So you are getting 1, which is not is equal to 0. So what we can say, the given functions y1 and y2 are linearly independent. One more problem we will do on this. Okay, next problem is verify the linearly independence of e power x, e power 2x, e to the power of 3x. Okay, now for this directly I am doing Wronskian is equal to how many functions they are given? To 3 functions. Those are y1, y2, y3. So y1 prime, y2 prime, y3 prime, y1 double prime, y2 double prime, y3 double prime. Okay, y3 double prime. Now here determinant of given terms are e power x, e power 2x, e power 3x. Now this derivative is e power x, this derivative is 2e power 2x, y3 derivative is e to the power of 3x into 3. Now again differentiation is e power x. Now 2 into 2 4, e power 2x, 3 into 3 9, e to the power of 3x. Now what I can take the common from these all, you see, instead of multiplying a determinant form, it is better to first we need to observe the each column is having common term. The first column is having e to the power of x, second column is having e power 2x, third column is having e to the power of 3x. If I taken these are common, then I will have the product of here 1 2 3. Next time 1 here what you have 1 1 1 only, sorry, 1 1 1. In the second line, that is second row, 1 2 3, third row 1 4 9. Now we need to find the determinant for this. Okay, now this is first you multiply e to the power of, bases are equal, so powers we need to add, that is e power 6x. Now find the determinant for this. Then 1 into 2 9s 18, 18 minus 12 minus 1 times of 9 minus 4 plus 1 times 4 minus 2. Now e power 6x into 6, this is minus 5, sorry 5 into minus 1 is minus 5 only, plus 2. So 6 plus 2 8, 8 minus 5 3. So 3 e power 6x, which is not is equal to 0. Therefore given functions are linearly independent. Okay, in this video we are discussed the Wronskian method to verify the linearly independence of the given functions. Okay, thank you for watching this video.